In the previous lab, you containerized the PHP front end and used it in the multi-container Fibonacci application. In this lab, you will simplify the multi-container application using Docker Compose. Let's get started. What is Docker Compose, or Compose for short? Compose is a tool for defining and running multi-container Docker applications. You use a YAML file to configure your application's several containers called services. With a single command, you create and start all the services from your configuration. We will use Compose to install our Fibonacci application, including the front end and the back end, with one command. You can find a PDF file with the full list of the commands you will run under the resources attached to this lab. Please download this PDF now and keep it handy to help you with typing the commands for this lab. Since you installed Docker Desktop earlier in this course, you already have Compose. Check the Compose version with this command. Look at the docker compose.yaml file under the Fibonacci sample root directory. The compose file defines the list of containers in the application as services. In our case, we have two services, one for the back end and one for the front end. You can see in the compose file that I am using images created under my Docker ID or Shukri. You can leave it like that and it will work since I pushed these images already to Docker Hub. If you wish, you can use your own front-end and back-end images that you created in the previous labs. In this case, edit the compose YAML file and replace Oshokri with your Docker ID. Let's compare the back-end service definition in the compose file to the command we used to run the back-end container in a previous lab. The instructions in the compose file define similar aspects to what we have in the docker run command. A network alias will be created. This allows the front end to reach the back end at the endpoint it expects. Specify container image. Append parameters to the container's entry point. Expose container port 5000 to host port. Define a volume pointing to a host path. You will need to change this to reflect the path you want to use on your Docker host machine. Where did the Docker network go? Compose will create it for us and will create all services under this network. Let's now compare the front-end service definition in the compose file to the command we used to run the front-end container in the previous lab. The instructions in the compose file define similar aspects to what we have in the docker run command. A network alias for the front end will be created. Specify container image. Expose container port 80 to a host port. Define the passphrase environment variable. Again, no need to create a Docker network or refer to it in the service definition. Compose will create a network for us and create the back end and the front end services under it. Therefore, the front end will be able to reach the back end. Change directory to the root of the Fibonacci sample application and run the following command. Note that the -d flag runs all containers in the background to avoid blocking your terminal. You can see that a network has been created as well as the front end and the back end containers. You can even tail all the logs from all the containers in the application using this command. The service name is displayed at the beginning of the line, often colored, to help distinguish messages. Press Ctrl C to exit the log tailing. Test the front end in the browser at port 30088. Log in with the passphrase and compute the Fibonacci of 35. The result shows v5.0 as we defined it in the compose file. Confirm that you can see logs written to a system.log file on the host machine. To tear down the whole Fibonacci application, simply run this command to stop and remove all containers and remove the network too. Removing the application does not affect the files we persisted on the host machine. The system.log file is still there, which is what we want. This helps us preserve state between multiple container runs. Congratulations on finishing this practical introduction to Docker. You have learned the concepts of Docker and containers, installed Docker Desktop on your machine, started with the Hello World container, containerized and ran your own applications, learned how to pass arguments to a container to change its behavior, created a multi-container application, first manually and then simplified using the power of Docker Compose. Great job on reaching this stage of this course. Head over to the next section for a practical introduction to Kubernetes.